Hey, welcome to SkyTour LiveStream for July 29th, nearly the end of July in 2020, and we still have Comet Neowise in the sky to look at tonight for a little while. And we also have Amanda Curran with us. Hi, Amanda. And she's on mute, I think.
Oh, no, I'm not. Sorry.
That's all right.
I forgot to mute YouTube and I heard the playback and it threw me. Hi, everybody. It's going to be one of those nights, I can tell already.
You just gotta
Hope everyone's
watch.
well.
You gotta watch the Skype because that's the live view.
I was on Skype, that's the thing. Then I heard the audio and I was like, where is this coming from? Why do I hear an echo? And then I realized there's YouTube in the background.
Gotcha.
Not on mute.
Well,
Yeah.
we
Okay.
also have Daryl with us to make sure that you don't do those kinds of things because you're such an amateur at radio, Amanda. As if
I'll do it instead of you, Amanda.
Not
I
at
screw
all.
up constantly.
No, Amanda's a pro at this. So, yeah, the three of us want to welcome you to SkyTour Livestream tonight. We are going to be looking at the comet, and we're also going to be checking out the Gibbous moon. And if we have some time, which I think we will, we are going to go cluster hopping in the summer Milky Way. That should be pretty fun too. I absolutely love looking at the different star clusters, and when you have a bright moon out, that's really kind of the best thing to look at. You can't look at faint, distended objects like nebulae and stuff, and not get a whole lot out of them. But I do have filters that can counter that, and it'd be kind of fun to test that. You might notice this on the screen here. This is, I will take care of a couple things here. This is our current view of a solar system and where Comet Neowise is with respect to the Earth. There is Neowise there. Here's the Earth here. So we can see from the Earth, it's already gone around the sun and it's heading back out. And of course, its orbit is incredibly, stupendously, colossally large. Okay, that outer ring you see there, that's Pluto. Now, it took us 15 years to get to Pluto, and Neowise is way farther away. Neowise is 715 astronomical units at the other end of its orbit. That's how large that orbit is. So that's pretty big, So there, and yes, Farva, this is Amanda you hearing. Yep, that is correct. Amanda,
Hi, Farva.
Yeah, Amanda's been an incredibly talented and dedicated co-host for SkyTour Radio on KGRAradio.com on Sunday nights from 8 to 10 with yours truly, and along with Daryl Mason, who is, of course, a colossally talented guy. Oh, don't give me that, Daryl. I know you're going to say, but you're not going to get away with it this time.
Stop it.
Well, then there's that, I guess. He's an astronomer as well, and he really knows his stuff, and it's fun to hear his take on the astronomy we talk about on SkyTour Radio and SkyTour Livestream. So that aside, and all this stuff out of the way, let's go to our live view. This is our live view right now. We currently have let me just get this out of my way. We currently have a green thing down there. That happens to be Comet Neowise right down there. And Comet Neowise is located, if we bring up the planetarium chart, it appears to look like it's in the house, but it really isn't. It's actually just above it. We might lose it behind the house. This is my house. This is the SkyTour Livestream location. There's the moon down in the south-southwest. This is the Scorpion in the summer sky here. And this is Sagittarius, the Archer, over here, more to the southeast. And this is the Milky Way you see here. And we're going to explore some clusters in the Milky Way, which we'll find through all these different objects that are in the Milky Way. And maybe as time goes on, we'll get to check out some of the other objects up here in Cygnus, the Swan, and Lyra. But we did some of that last night, but now we'll do it here again. But we're going to first look at Neowise until we lose it behind the house. Like I said, it's not quite behind the house. It's actually more around here, actually. And the telescope pointing is off by just a couple degrees, which is a lot for astronomy. But it's actually not off physically. It's off in this program, and that's okay. I don't need it to be perfect. But anyway, so there you go. And once it gets out from the house, it'll be in here and it'll go down behind the trees over a next hour or so. So anyway, we'll keep looking at the comet up here for now, and we will bring it back and check it out. So here we go. That's the comet there, and this is our telescope view. I saw some new faces out there, which is wonderful. Welcome to SkyTour LiveStream. And I wanted to just give you a quick tour. This is the telescope control system. This is me. Hello. This is the camera control over here on the right side of the screen. And down below here, this is the observatory cam system. And from time to time, if there's something going on in there we want to look at, then I can just bring that up so you can see what's going on out in the dome. So that's sort of the tour, and then the live view is here. So let's actually do a shot. Let's give ourselves, say, we're going to go at, say, this is, again, the camera control. We're going to go up to 1250 ISO, or sensitivity, and let's do 25 seconds, okay? And this will be Comet Neowise right there. All right, and then we'll talk about what we're getting. So the exposure's underway, and then over in our reviewing area, this is this actually gives us an idea of what we're looking at. This actually tells us exactly what we're looking at, and the comet will replace this image here. This is a image that shows some tracking errors, but that's okay. I'm working on that. And this is more what it's supposed to look like. Now, in this image, what we look at, we see this beautiful green coma. And, I know when Daryl looks at these comets, he tries to find them. You said you were not successful finding Neowise with your binoculars, Daryl.
I have been completely unsuccessful in seeing the comet anyway, whatsoever.
That's understandable, because tonight when I went to look for it with the telescope, I went exactly to the coordinates where it said it was, and it wasn't there. It's wrong again up on the skylive.com, which is the place that we go to actually get all of our data, and it was wrong again. So I literally had to hunt for it, and I found it, and the location where I found it was a substantial amount off from what's published, but that's okay. We found it, and that's what matters, right?
Yeah, it is dimming rapidly too.
Yeah.
I read somewhere a couple of days ago that it has decreased in brightness by 25-fold.
Wow. Yeah, okay. So in terms of magnitudes, it used to be magnitude almost 1.9, which is very bright to the eye, and then it was magnitude 3 almost the next day, and then it's gone to magnitude, well, they think magnitude 8 right now. At least that's as published. I don't know if that's true, because to me, taking the pictures in here, this photo, again, is a photo we just took, and to remind you of what we took it at, right, when I come back to the screen here, it was 25 seconds at 1250 ISO. Okay, we're going to crank that up. We're going to go to 6400, not 8000. All right, and we're going to do another 25-second shot. So that's going in the background. Meanwhile, we'll go back to the shot we just took. And when this new shot comes in, it'll overlay this one. But look at all the stars in the field of view here. This is really pretty. We are looking at a white light view, by the way. Many times I will use the filters on the telescope. And we don't have any filters in the opening right now. I've actually got a wheel, and that wheel rotates with different circular 2-inch diameter filters in it. And that filter will show us different aspects of the light coming from the comet. It'll actually show us certain frequencies better than others. And right now, this is the white light view, because the white light view shows this green better. What's interesting about the green, and Daryl, see if you follow this as well and concur. When we look at the coma, this bright central section of Comet Neowise now, the bright coma here, it looks like it's the biggest it's been since we started looking at Neowise. It looks as more distended, I should say. And that might, and what's interesting is the comet, they said, was at closest approach to Earth several days ago. But what I'm looking at here shows a coma which looks a little bit bigger than what I remember.
It's hard for me to say. I think it's a little smaller. But then again, I'm trying to keep in mind that the comet is moving away from us fairly quickly.
Yes, it is.
And thus getting smaller in the sky.
Yeah.
Would you care to differentiate between the coma and the nucleus for the people?
Sure. The nucleus of the comet is the central body that's actually causing everything you see right there. This, for instance, this thing in my hand, this is a 3D print of a comet core, comet nucleus. This is Churyumov-Gerasimenko. It's the comet that we went to with the Rosetta mission, and these can be anywhere from 1 to 2 miles across to 6 to 10 miles across, maybe a little bigger, and they're icy bodies that are kind of like, think of it as a spongy frozen terrain, and inside the spongy areas and the voids in there where you might normally expect there to be air, like on Earth, you might have gases that have been frozen in their ice. And as the comet gets nearer to the sun, the surface of the comet heats up, and that will heat up the inside of the comet, and those gases might find a way out, and in certain little pockets they'll just go and they'll pop out and make little geyser jets of gas. They also take with them dust and material that's covering the comet for billions of years, and that flies off too and heads off the comet. And the stuff that we see around the middle here, around the center of this head of the comet, this stuff is the result of interactions with the comet's surface by the solar radiation doing the heating, and the stuff's popping off the surface, going up into the area around the comet. That's the coma. That's this part here, all right? And so there's the nucleus is causing the coma to be seen. The nucleus is outgassing this way and causing that. So that's actually pretty cool. And the green color comes from interactions of the ultraviolet radiation from the sun with a molecule called cyanogen, which is a carbon and a nitrogen atom together, bonded together, and also diatomic carbon, which is CC, and about 25 other carbon compounds, in fact, in the comet's chemistry composition. So what happens is...
And Genghis was just about to say that. So is cyanogen something common given off from the comets we have seen? Is this common for all comets, or just this one, or?
No, actually, Genghis, well done. This comets generally have a cyanogen component, as well as a 2 diatomic carbon component, and other formaldehyde component. They have carbon dioxide component, water, okay, which of course has no carbons, but it has many compounds, all right? And all of those compounds can also be considered the precursors to the materials that would become the building blocks of life. So one comet strike on a planet that has an atmosphere could bring a significant number of compounds to the planet that might allow life to jumpstart on a lifeless body if it had an atmosphere that would support it. But most likely, if it had an atmosphere that supports it, life will already have begun because of the nature of how planets operate dynamically. I'm referring, of course, to an experiment done in the 50s called the Miller-Urey experiment. And by bombarding a primordial atmosphere in the flask with an electrode that was going through the glassware to simulate lightning, at the end of a week, they actually had the building blocks of life forming as a black sludge on the bottom of this flask. So you see, in Star Trek The Next Generation, when John Delancey as Q says, you see that goo, Picard? That goo is you. And he's showing Picard the early Earth, and he said, I could stomp out humanity by just killing this goo, kind of thing. You know, he was really a jerk, you know, in the show as a character.
Well, he was.
Yeah. But
he had his moments, though.
He did indeed. And he actually was, I actually thought that when Delancey made his appearance as Q, I was worried that Star Trek might jump the shark, because I didn't like all the fanfare. And jump the shark means, you know, in an attempt to recover ratings, they make this leap of in craziness that, you know, is just really removes the appeal to the show for so many people. Not for me. I mean, I stick with it anyway, you know. And Jump the Shark came from when Fonzie in Happy Days jumped the pool with a shark in it at the restaurant there.
It wasn't a pool.
Well,
weren't they in Hawaii or something? Was he out in the ocean?
I thought that was at the restaurant.
I don't think so.
Okay.
It was Happy Days. It was Fozzie literally jumping a shark, but I thought he was on water skis and it was in the ocean.
Really?
Maybe they weren't in Hawaii, but
I thought it was a motorcycle.
I thought he was on a motorcycle.
Yeah, me too.
On a motorcycle?
Yeah.
Why am I visualizing? Okay, chat. Okay, well, actually, you know what? I'll do it myself.
Sure.
I'll be back. Google is my friend. I so clearly remember being water skis and he went off a ramp.
That could have been.
How could I be so wrong? Hold on. No, it's 2 against 1 right now.
No,
I'll verify.
I kind of remember him like jumping a kiddie pool that had a shark in it at what
kind of shark?
I don't know. Okay.
It was bad editing. It was supposed to be a real shark,
it
but
was
like
a rubber shark
in a kiddie pool. Oh no. It was a real shark.
And he fell off.
For sure.
Yeah, well, it was. No, it wasn't a rubber shark.
No, he was successful.
Okay. Since, you know, we remember things differently anyway, but I don't want to fight about that. I want to hear about what's right here. And if you're right, okay, cool. I want to say hi to Genghis and Marianne and Tara and Katie Q and Daisy and Zoe. Welcome. And James Dugan is here. Papa Tom is here. Danny Fan, who the heck is that? Get her out of here. That's Amanda, of course. Hello, Bob. Nice to see you here again. And Sean Farva, of course. Sean Farva has been a wonderful patron of SkyTour LiveStream. I just want to thank you for all of that. You are a really good guy. Rascally Rabbit is here as well. And yeah, Greggy Gilligan. Hey, how you doing? And you, I forget where you were from, Greggy. Are you from... You told me where you were from before. And Terry Groff is here. You let me know, Greggy. You tell me where you're from, because I know you told me once before. So anyway, how is everybody doing tonight? It's a good night. We got a great comment to look at. It is getting fainter, but you know, it's okay. And Weird Guy's here too. Yeah. So we're actually having some fun here. We are looking at the comet in white light, so the sky does have this little bit of light pollution in it. Down, we're kind of lower in the sky now. We're actually over the house right now, so it's probably not the best atmosphere because the house is radiating heat. And it looks like it's getting dimmer, which would say to me that it's starting to go behind the roof, which is crazy. Either that or clouds. Let's just do a 20-second shot here to see what's going on, because we may have to change over to the moon. No, Andy, I didn't have a shark attack.
Q had a shark attack.
Q had a shark attack?
No, it was Fonzie.
Oh, Fonzie.
And Amanda's right. Water skiing Fonzie.
I remember the episode, but I thought I remember him at what was the name of the restaurant? I want to say Arthur's, but it wasn't. Right?
Alice Steiner.
Al's. Okay. Yeah.
Arthur Fonzarelli. That's where you're getting Arthur from.
Mm-hmm. That's right. Okay. Well, see, Amanda showed us up, guys. Yep. Swim trunks and his leather
It's weird
jacket.
that you both remembered being like a little kiddie pool and on a motorcycle and stuff. I'm sure he did do stunts like that, like motorcycle jumps and stuff. That sounds familiar, but that shark was so clear.
Okay.
Yeah.
Well, see, that's what they
and
mean.
now you've learned something today. You can all rest easy.
Yeah, not that we were resting uneasy. But yeah, okay. It looks to me like the comet is going either that's behind clouds or light clouds. You know what? What am I doing? I can figure this out. All I have to do is take a exposure here. This is the other camera. This is the wide angle camera. So I'm going to just grab a. Let's see. We're gonna shoot this at. Let's go up to 2,000, and let's do 15 seconds at 2,000. All right. So there we go. So now we're gonna take a 15 seconds at 2,000 shot here to look and see if we've got see what we've got the comet entering the house or not. It could.
All hail Amanda.
Yeah. She wins. She wins.
No, it's not right. Not often on a stream where I'm absolutely certain of something and I can prove my point, because usually I'm the one asking questions, but very few times. It's like one of those Jeopardy things.
Yeah.
General trivia that really don't matter until the one time in life that it does.
Yeah. Okay, here is.
That was a good show.
Yeah, it was. Here's the roof, right here, and you can see there's a cloud here, so that's what's going on. There's a high altitude cloud that's getting in the way of the comet. Kind of a cool shot overall, if you think about it. But I am going to take us to. Oh, this is only 800 ISO? That was a mistake. I wanted to go to 2,000. Now we'll do it. We'll do 15 seconds at 2,000. That was 800. I thought I'd made 2,000. Sorry. And we'll get our response, and see what it looks like. Well, thank you, Farva. Thank you again.
Thank you, Farva.
All right, and now, there we go. So now you can see these clouds a little more. You can see what's going on there. And we have the comet. You can see its tail right there. And we can zoom in too. All right, but to be honest, when you zoom in, you have dispersed so much of the comet. So much of the images is taken up by all of this that when you zoom in, you have a relatively fewer pixels that are here, which is why zooming in on a really nice, high-end camera shot like this still doesn't show very much, because of the fact that you are in a position where you're trying to catch as many pixels as you can in the comet itself. But the comet itself doesn't actually have okay, look, we're kind of clear here. Doesn't actually, oh, there goes a satellite. You see that right across the bottom? Yeah, I don't know if you saw that, Daryl.
I didn't see it.
I missed it.
Yeah, it went literally horizontal. It was a north-south polar bird, probably a military spy satellite.
If anyone caught it and had a timestamp, that'd be great.
Yeah. Yeah, Terry Groff. That's where the term "jump the shark" comes from. That's why I brought it up earlier, because that's exactly what you say. It's Zachary, what you say. Okay, let's go take another shot here. Say 10,020 seconds of the comet.
Genghis is wondering if the comet looks like it's gonna survive this round with the sun.
Yeah, this time it'll survive. We don't really know. We don't really know what the comet's nucleus looks like. We know what Churyumov-Gerasimenko looked like because we had a probe circling it for 8 months and taking photos of it. But we didn't have that luxury with Neowise. We never could get anything out to Neowise. It wasn't planned. There was no intention. But hey, you know, it's what it is, right? And so we get to see what we get to see. Yeah, so you can see this light hazy. These are clouds here. So what we'll do is we will shift over toward the southern sky, because Neowise is going to get blocked out for some period of time, and we won't get to see much going on in here. But it really is a pretty green. Actually, if you notice, the green actually matches Farva's comment there, so that's kind of cool. That's a cyanogen comment, Farva. Cyanogen comment. Not bad. All right, so let's do this. Let's go back to our main view here. And this is where, see, I wouldn't care if I had a roll-off roof right now. You wouldn't see the dome. You'd just see the sky. We're in this view down here. That's over here, but we don't have that yet. So I'm gonna go out and move the dome, and when I do, you'll see the comet disappear from the view. But we're gonna head over to here. Okay, we're gonna come out and zip around, and we'll just go look at the moon for a little bit, and then we'll head into the summer Milky Way and look at a lot of the clusters that are over there. How's that all sound with all of you? Okay, good.
Sounds like a plan.
Yeah. All right, so I'll be right back. And I think that you and Daryl can probably manage all the folks that are out here watching us, right?
We'll see.
Nah, we don't have to see. You're good.
Crack the whip.
Yeah, crack the whip. Oh, that's funny. That's funny. Yeah, not a problem.
Straighten up, everybody. Especially you, Ronald.
Ooh. Ronald's here, too.
Hello, Ronald.
All right, I'll be right back.
Yeah. You're sounding a little quiet again, Daryl.
I'm sorry.
It's okay. I feel like I've been having audio issues for a week, so maybe it sounds good for the chat. Last night, Mark was saying something, and it totally dropped out for me. Like, I missed a complete sentence, and I asked him to repeat himself, because I thought, like, his audio, like, froze or something. Seems like everyone else in chat heard him. It was just me. So, guys, let us know if we sound all right.
Amanda can crack the whip on me any old time.
Did you hear about the launch to Mars tomorrow morning?
Which one? The Perseverance?
Yes.
Oh, I forgot all about that.
Yeah. I can't remember the time. I want to say it's like, I don't know, like either 7:30 or like 7:50 Eastern, I believe, a.m.
Huh.
Does that sound right?
Don't know. Let me look it up.
Okay. I asked Bill last night if he was going to stream it. It doesn't look like he's going to. I think it's too far from P&K, and I don't know if Mark is really in any position to catch it. I just figured someone would pick up like NASA's feed or something. Because NASA supposedly lets you stream their material for free as long as it's for education purposes.
Yeah. Scheduled launch on 30th July at 11:50 Universal Time, which would be, what is that?
Is that like Greenwich Mean Time?
Basically, yeah. Universal time for me. Well, heck, now I got to figure out daylight savings time in bed again too. It's usually universal time is -7 hours here, except for daylight savings time, I think it's -6 hours. It should be 5:50 tomorrow morning, my time. I'll probably be up then. I'll try to remember to dial into that. Hopefully I'll see it all over the web tomorrow morning.
Okay, Katie's saying 10 to 8 a.m. Eastern, and that's what I was thinking too.
The rocket launch?
Yeah. You have no intentions of carrying that, do you, Mark? The NASA coverage or anything?
I'm not going to stream it because it'll be a copyright violation.
Not if it's NASA, I don't think so.
But it's 10 of 8 in the morning. Yeah, us astronomers don't get up that early. We were sent.
Oh, maybe I am an astronomer deep down then.
Yeah,
I don't usually get up that early either.
I know. I love it. So here's the moon, and I will drop down all our settings here to bring us to something reasonable. Let me just bring that down too. Okay, so okay. So here we are. Now what I'll do is drop us here, and the moon will take on a new look. Here we go. All right, so we're approaching a waxing gibbous phase. We're a 9.3 day old moon, I believe, and we can look. The moon is just really, really inordinately bright, you know, so we have to drop down and lose a lot of the brightness. But I wanted to show you one thing in particular. Last night the Terminator was right about here, okay, and we could not really see this crater. We could see it was dark. I was showing you yesterday.
Clavius?
Yeah, and now what I'll do is I will take another picture of it, and I will get rid of this. Okay, let me do this. Amanda, read that comment from Farva.
Thank you, Farva.
Okay.
Sound like there's a new president of your fan club, Amanda.
Yes. Okay, so we zoom.
I appreciate the support. Thank you.
So in this one view, we see Tycho. Okay, and right down here we see this crater called Clavius, and Clavius is the 3D print that I showed you yesterday. This is Clavius. Well, you can't really see it too well. Okay, but Clavius is actually this is a really nice SLA print that we do here. And so Clavius is one of the ones that we do. We actually do everything on the moon. People can get they can get these guys right here if they want to. They just have to make sure they're careful about telling us. Yes, Copernicus is very nice. I actually have Copernicus up here too. It's right here. This is Copernicus right there. And now that is just a pretty location as well. We'll take it with a little bit more light. It's just really pretty. Gosh, I love it. It's just like, it's the bane of astronomers, because it throws so much light on our subjects that we don't like. We can't do studies of nebulae while the moon is brightly lit like this. But when we get to this phase, this gibbous, approaching gibbous like this, after first quarter, it's all downhill from there for us because we lose a lot of the ability to take deep sky photos during that time. However, if you have a special filter like we have, we can actually continue to take the deep sky photos, and it's just really cool. Even with a full moon, I was able to take pictures of these nebulae that were just beautiful, and you couldn't tell. Like the veil. The veil is really hard to take a photo of in a bright moonlight. We did it. These are the lunar highlands down here. Okay, this area is very, very high, and on the other side of the moon, on the far side, it's actually looks like this everywhere. There is no dark Maria like this, except in a couple places. Right about here on the other side of the moon, if you just go straight through, that's Mare Moscoviense. And then down here is, on the other side, is the crater called Tsiolkovsky. I can't spin the moon around and show you, though, unfortunately. But that's the way it goes. Farva, thank you, man. But nothing to forgive. Amanda has a really lovely voice.
Thank you. I appreciate that.
Well, Farva said it, see?
Yes, I know. Thank you. We appreciate the support.
Yeah.
You're what
we really do.
Keeps Mark going and able to open his second dome and observatory down in Arizona. Yeah. And I see Marianne is here as well.
Yes.
She's been
Marianne.
Nothing but the greatest of help to him. So
yeah, she has.
It's a wonderful community. Thank you all for being here and coming back. And if you want to tell a friend and share it on your social media, that would be great.
Absolutely. We really need the support, and like I said, our second observatory, by hook or by crook, we're going to make sure that gets built, just after August 15th. And I've got to get the computer outfitted and the all-sky camera, and we're going to permanently attach the all-sky on this trip. And we'll be able to get the all-sky shots. And then later on in August, I'll go back with all the equipment and do the install over a week. Because it'll probably take a full week to install all the equipment out there. Because, it's not a... Well, you know what it looks like. I mean, you saw what it looks like when we actually do this, This is the telescope system here. Okay, and I'll just bring this up here for you real quick just to show you. And when we're, you can't really see too much there, but I can actually show you by dropping the camera a little bit. So when we drop down the camera here, you'll see there's a lot going on here. This is a pier. This is a special wedge shaped piece that gets it polar aligned. This pier that you see here, this pier right here, this is a solid, not solid, but a tubular steel pier. Weighs 160 pounds, just the pier. Telescope weighs about 350, 400 pounds. And you don't want to drop something like this. You have to be really, really careful. And then we have all the ancillary gear on the telescope. Like this is the opening of the telescope here. And to close it, we have a cover. Well, I can't put the cover on it out in Arizona. So this system here, this is a stepper motor right here. And I programmed it with a program that's actually let's see, it is here. This is the way. This program here controls the stepper motor and the entire observatory process. And what it does is it allows the telescope to be turned on, turned off, the roof open and close, and the opening and closing of the telescope. And it can also, I control the order which we can do that. You can't do it anytime you want. You have to do a certain thing. So I have timers, for instance, that are going to turn on the computer. I have timers that are going to turn on the electricity to the building at a certain time of day, because out in the desert, it could get well over 120 inside the building. Now, thanks to Marianne's thoughtfulness, she actually thought of putting in a solar vent that will start venting hot air out of the building when it gets too hot. And so that's going to be installed too, and it's going to be a metal roof. And then the the power will be turned on around 5:30 in the afternoon every day to the building, and then at 6 p.m. the telescope's computer, the computer that runs the telescope, will be instructed to turn on every day at 6 p.m. And then we can use it and start it up, get into the observatory, check things out, get ready for a stream, do the streams, and then once we close it up, we will shut everything down, and the power will then be shut off automatically at 5 in the morning every day. 5 in the morning, power goes off in the building, and 5 in the afternoon, 5:30 in the afternoon, it comes up. So what we're doing is avoiding the heat of the day for the building, because it is in the desert, so we do have to consider that. So heat is a problem for instruments, and we have to be careful. There's certain operating temperatures for instruments like this, and the operating temperatures can be, they're below 150 degrees, and so most things will operate. But you never know. I mean, we may have to make some adjustments, and that's what the installation process is going to be all about, to try and figure it out. So that is there, and so we're going to get views of the moon, for instance, and Copernicus here is looking really nice. But we'll get views of the moon that are going to just be staggering, and we'll get views of the stars and the star clusters that will be absolutely unbelievably stunning. Not a worry in the world about that. I'm actually so excited about it that I really lose sleep sometimes. I really do. Hey, Farva, thank you, man. Oh, yeah, you know what, Farva, you know what? Anything that you do for us is appreciated. You have to understand that. And we appreciate you too. Thank you very much.
Mark, with all the details you mentioned about the Desert Observatory, my first thought was, A, are you going to have a wiring diagram, or is it all going to be in your head? And B, extrapolating from that a little bit, are you going to write a handbook for your observatory?
Well, I can't expect that I'll be the only one to run the building, because there might be a day when I can't do it, and you may want to, Daryl. And so I'm going to have a handbook and a foolproof way to start up the building so that no one can get in trouble. Like shearing off the telescope by shutting the roof when it's sticking up. Things like that can't happen. But I do fully intend to be able to offer the building to people to use it. You've earned the right, obviously, and as people are trained, they will earn the right as well. We have another streamer group that's going to be renting the other pier in the building. We're doing 2 piers in the building. And they are just absolutely so on board that you can't believe it. So this is really good. So we're going to basically get some streaming income from these guys. And that'll be helpful because we're going to be paying for electricity. Not really, because the electricity is coming from solar, but we're going to be paying the internet bill to help boost the internet capability there. Because we're going to be using a lot of bandwidth for the uploads. Downloads, not so much. Uploads, that's where this is all coming from. My upload speed here has to be really, really good throughput and high bandwidth to actually do this. Hey, Dave Byrne, how are you? Using a PlayStation, that's pretty cool to actually look at the stream. That's neat. I've actually seen that. Is it sort of like through your television? I know people were watching our stream via Roku at one point, and I think that's pretty cool. I think it's great, a lot of technology out there to help people, All right there, Papa Tom. Thanks for coming along. Look, here's the site of, was it Tycho? Is it TMA1?
Yes.
Right? TMA1 was in Tycho here. And that's, if anyone knows what that is, this is your little quiz for the chat, okay? What was TMA1?
I know, so I'll keep my mouth shut.
Yeah, it's a quiz for the chat. Yeah,
I think we've asked this before.
We have, and I want to see who was paying attention. Hey, Anahata, how are you? Nice to see you here, Bonnie. Oh, yeah, this TMA1 was in Tycho Crater, and that's as much as you're going to hear. Yeah, and it's from a movie. It's not real. I wish it was. All right, so let's go back and take some more shots here.
There was something in Clavius Crater, too.
That's correct. A very, very good point. And let's make sure people... if you answer what TMA1 was, you then answer for extra credit what was in Clavius Crater, as Daryl just mentioned. We like these things. We like this stuff. Ha 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 ha.
I love Clavius Crater. That's just so cool looking. It's got that... It looks almost like, you know, somebody did it on purpose. It's got those 5 craters in a curved row, and they sort of step evenly in size from small to large.
Yeah, they do actually. And there's one bordering the northwestern side, one bordering the southwestern side, big one. And then, of course, you got the main crater, and then you got the other little craters that are in that little circular, ever getting smaller arc. Tara! Look what Tara said. Wow.
Tara wins.
Yeah.
I didn't know the answer, so I was waiting for confirmation. Yay, congratulations, Tara.
Yeah, the monolith from the movie 2001:
Oh, wait.
Space Odyssey.
TJS said it too, a little bit before that. Wild guess,
Oh,
the monolith.
You're absolutely right.
Ah.
Yeah.
Oh.
TMA1 stood for Tycho Magnetic Anomaly 1.
That's right.
Ah.
Well, TJS, first of all, welcome to SkyTour LiveStream. It's good to have you here with us, and thank you for joining us, and as well as you, Dave Byrne. Yeah, okay, so David is watching on the TV, but the chat is on the phone. That's very cool. Yeah. Yep. Yeah, that's right, Charles. Little late to the party there, Charles. That's okay. That's cool. There was delays, so you might not have heard that before you wrote it. But then, what was Clavius Crater? Tell us the significance of Clavius Crater and this Tycho Magnetic Anomaly 1. And that's something that's pretty cool. I mean, I like the concept that was promoted by that book. Oh, yes. Okay, so let me just get us.
I have a few questions coming in.
Okay, sure.
I kind of want to rephrase Ronald's question. He's asking, if the moon was split in half, would that have any effect on the gravitational activity? I'm going to say it probably would. So how? How would that affect the gravitational activity?
Okay, the mass is calculated by taking the gravitational force is calculated by taking this constant, capital G, and multiplying it times the mass, dividing it by the radius squared of the object. So if you cut the radius in half, that's going to reduce and the mass is getting reduced as well, then you're going to have a much smaller gravitational force. So if you cut the moon in half, all right, then you're not going to be at 1/6 Earth's gravity anymore, are you? All right, I'll give you one guess as to what you're going to get, Ronald. Okay. What's half of 1/6? Yeah, you won't answer right away. You're going to actually reduce your gravitational force to 1/12 of the force if you cut it in half. And so it's going to be one of these cases where you're going to end up with tides that are going to suddenly change on the Earth. But if you have two lunar bodies, two two things that are rotating around the Earth, then you could really have a disruptive effect on the tides, because you'd have all kinds of crazy tides occurring that no one's really ready for. They won't be like every several hours like clockwork. It won't be every 12 hours like clockwork or whatever. It's going to end up being maybe every 8 hours or 6.5 hours, one particular tide. Then when the other rubble piece comes along, it's going to be another tide. Oh, it could be a real mess. So let's just hope that it never happens, okay? Say it with me, Ronald. It's never gonna happen. Yeah.
Okay, let's play hypothetical.
Okay.
How could that ever happen? What kind of impact would crack the moon in half?
Well, if
like something twice its size, like an asteroid twice its size or something.
Well, there are no asteroids that would be maybe twice the moon's size, really. Okay, because those wouldn't be asteroids. Those would be, at the very least, dwarf planets, and most likely small planets. So, I think that I think the issue really comes in when we actually look for instance, impacts that would hit the moon to break it in half. Probably, we're talking about something that if it did that to the moon, it's certainly going to affect us too. All right, it'll have gravity enough to affect us as well. So I don't know about that. And Gibbous is asking for Rupees Recta. Yeah, so that's Huygens' sword.
I was gonna ask. Yeah.
Yeah, and that's like that should be right here. Let me see if we can see it.
Yeah.
Let's go.
He asked an earlier question too, which I like.
Yeah.
If we were to dust off Luna, would it be any more colorful?
Oh, that's interesting.
Mm-hmm.
Oh, well, here's... okay, well, we're going to look at Rupees Recta. I think this is it right here, isn't it not? Daryl?
Maybe. Hard to say.
Okay.
Probably is.
All right, let me try a little bit of zoom. I think...
Yeah, yes it is.
Okay, this is Rupees Recta, so this is Huygens' sword. Gibbous asked for that. But I want to draw your attention just above it to this area. It's one of my favorite areas on the moon. I'll tell you why, okay? This is an area where the moon's soil is a distinctly different color than elsewhere on the moon. And I tried to look for it yesterday, but the moon we just didn't quite get enough showing of the moon. We didn't quite have the right phase. But now that we do, we can see this amazing color difference. This is almost orange soil. Isn't that cool? So that's...
It is.
Yeah, so this is like a weird orange soil location. And there's your Rupees Recta, which is basically the straight wall. And actually just below it is this really interesting feature, which I don't remember what this was. Daryl, you probably remember. This...
No, I don't. Not offhand.
Okay. Well, we could always figure it out, right? Because we now, as of yesterday, folks really enjoyed the Lunar Reconnaissance Orbiter Quick Map quickie that I showed you. And that's something, if you looked up LRO Quick Map, you'll find the moon in unprecedented detail, and you can keep zooming in to levels you can't possibly believe you can do, thanks to the Lunar Reconnaissance Orbiter that's circling the moon between 30 and 60 miles above the moon. So you get to see things like the Apollo landing sites, like where the lunar modules, when they were discarded from lunar orbit, when they were coming back, you actually see this long, shallow strike in all the debris field of this lunar module. You can see it from space, from the Lunar Reconnaissance Orbiter. Really, really cool stuff. Because that's something people don't really think of. They had these lunar modules, they went down, they had a descent stage. The descent stage and the module on top were two pieces, right? They land on the moon, and when they leave the descent stage on the moon, and this part here goes up to the spaceship, up to the command module. They dock, and they come home. What people didn't realize is, they didn't think, that part that disconnected was discarded from the command module. And because the command module was in a lunar orbit, it was discarded, and it went around the moon and slowly decayed in its orbit over time, and eventually hit the moon at a very shallow angle and very steeply, and not very steeply, a very shallow angle. And so when it struck, don't forget it was an oxygen-filled containment vessel, basically. When it struck, when it broke, it exploded outward and went poosh, and all this stuff just went and sailed for miles, 100 miles actually, in this linear direction along the strike path. And you can actually see some of those scars on the moon where this actually happened. Really cool, and you can see them from the LRO quick map. Right, so really, really neat stuff. It's really, really cool to come out here and check it out. And I encourage you to look at that. And if you have any questions, you let me know, and I will answer them for you, or Daryl could, about the moon. If you need to learn how to use the quick map, I don't think Daryl's up on it yet. I could be wrong, but if he is, you can ask him too.
I learned, and then I forgot it again.
Well,
I need to use it more often.
You want to know something?
Everything.
The truth is, they changed it a lot, and so I had to go through and do a refresher. Marianne, good night. So Marianne is heading on out of here. So Farva's saying...
We have a question. Yeah.
Oh, you asking about Farva's question there in the...
Yeah, I'm not sure what he means, though. When Jupiter departs, what happens to Earth?
I mean, maybe he's saying if Jupiter was to leave, what would happen to Earth?
Hypothetical, yeah.
And those are fun questions. If you think about it.
I love them.
Yeah, they are. Because... and I'll get to your question too, Tim. If you think about... If Jupiter was to depart, we ask, well, what is Jupiter doing for us? Jupiter is really, really far away. Actually, we can see Jupiter tonight if we just move the telescope a little bit over. But if we consider that the moon itself and what it's doing for us Jupiter's doing for us it is actually shepherding the asteroid belt for us. It is managing the asteroid belt and making sure that nothing out in the asteroid belt can be disrupted enough to come into the inner solar system. That's what it's been doing for billions of years. Not consciously, of course, but what it's doing is it's acting like a guardian planet, because it's the biggest gravity well in the entire solar system other than the sun. So if Jupiter was to go away, well, then all bets are off. We could have a lot more near-Earth objects, near-Earth asteroids coming into the inner solar system. And because if it went away catastrophically and just vanished, let's say it just went boop and it was gone. Well, now what would happen is wherever Jupiter was in its orbit, it's tugging on the asteroid belt, which is closer to the sun. Like my head's near the sun. It's closer to the sun, and these asteroids are orbiting, and they're going faster than Jupiter. Jupiter's in a farther orbit, so the asteroids are orbiting faster. And as they're orbiting faster, they're getting tugged a little bit out of their orbit and toward Jupiter as they go by Jupiter. Then they return to their place. Well, remember, they're being tugged. So if Jupiter went away catastrophically, now we have an entire section of the asteroid belt it's being tugged outward toward Jupiter a little bit. And then those are going to relax and come in, and nothing's going to stop them because Jupiter's gravity is no longer there. So they won't relax and come back to a gentle, resonant halt. They will actually continue, and they'll collide, they'll bump, and we might end up with some catastrophic behavior in our solar system for several million years until another resonance is set up to protect us again, if at all. But if that happened tomorrow, we'd be in big trouble. You know? Hey there, Johnny Unitas. What's up? I'd like to let everybody know, football legend Johnny Unitas is here in the chat. There he is. So anyway, was there a question, Amanda, that you...
There was. Oh, well, you were going to get back to Tim's question first.
Yeah.
About the spire on the moon.
Yeah. As far as the spire on the moon, honestly, we have never been able to pinpoint what the spire, if it exists or not, or what the spire is. Now, the problem is that when we look at this object, it could have been an area where a volcanic outgassing event occurred, or an outgassing event had occurred, and instead of a spire, what we're actually seeing was a photograph of the smoke or the dust going up into the air. Going up into space around the moon. Or it could have been some kind of an impact, but impacts tend to make broad craters and more splashes that are wider. This was a tall looking thing, so there's the thought process that maybe this was some kind of a outgassing event. But again, we don't know. We don't know for sure. So what was it?
That sounds like an example of a whole class of phenomena some people study called transient lunar phenomena.
That's correct. Indeed, that is. And I really think that transient lunar phenomena is actually an awesome field of study. By looking at the moon right now, we see some really cool, things on the moon. And if we actually move the moon over here, all right, and go like that for there now. Let me get rid of this for now. Okay, and now what I'll do is I'm going to crank up. The exposure. Yeah, the moon's going to get big and bright, but what's it also going to do? It's also going to show us this other side here. It's going to show us what's off in the dark, just a little bit. So if I actually take us more to the side here, okay, let's see if we can catch that magic moment. Oh, the telescope's doing the old lens flare thing. Yeah, that's not going to work that way.
Yeah, I'll be back in 1 sec.
Okay, we'll be here. Okay, there it is. So you can see this is the side of the moon that's currently not lit. And I can actually maybe do this by... Let's do this. I want to show you a little bit of this. Okay. So let's take that picture. It'll be 0.6 seconds for 800. Okay. All right. So what we've done is we've taken a photo of the moon, and you'll notice that we can actually see features on this part of the moon that are hidden in the dark. They're hard to see, of course, and we can't see them perfectly, but you can see that there's features there. Now, why are we seeing this? Isn't this supposed to be all in the dark? Why is it showing it all? Well, the reason has to do with our own planet. Daryl knows this, I know this, and now you know this if you didn't before. It's called Earth shine, and the Earth is a bright blue ball as seen from the moon. Many times it's mostly white because it's got a lot of clouds, and that reflects on the lunar surface, and that soft glow coming back is what lights this up over here. And that's the part of the moon that we don't see until it gets a little further around and the sun illuminates it.
There's a fairly well-known image of the solar eclipse in 2017 where it was probably a composite image. One, they shot the corona around the eclipsed sun.
Yeah.
But two, they shot a long exposure of the moon as it blocked the sun. The moon, by definition, was about as new as a moon could get when it was in mid-eclipse. You know, it was completely covering the sun.
Yeah.
But conversely, from the moon's point of view, if they looked up in the sky, they would have seen a full Earth. That is, the moon and the Earth are in opposite phases to each other. When it's a new moon, it's a full Earth.
Yeah.
When it's a new Earth, it's a full moon. And the finished image shows you can actually see the face of the moon and all the lunar features there, like the rabbit and the craters and all that, in what was formerly a black disk. That the details on the face of the moon actually showed up in the image.
Mm-hmm.
It's a really cool looking picture too.
Was that an astronomy picture of the day or something?
Something like that. I think I have it on my computer somewhere. I'd have to look for it.
Yeah, I'd like to see that. Yeah. I'm glad I could resolve your question, Farva. Over the course of the night, when looking at the moon, sometimes you can actually notice, if you do careful analysis of the craters and the shadows, you can notice that the crater shadows have changed just a little bit from early in the night to later in the night. And that's because, of course, the moon is moving and the sun is, basically rising on this section over here. So that's what happens here. Also, the Lunar Reconnaissance Orbiter data can also give you interesting data about the lunar temperature at night, how cold the soil becomes. And there's places on the moon where we could find ourselves safely safe from ultraviolet radiation if we are like under the moon's surface. And so we're looking for lava tubes and so forth on the moon where we can actually put a base. And there's some that have been identified. I'm going to actually check something tonight. We did this last night and couldn't really see it last night. Oh, maybe see it tonight. Okay. I want to actually see if we can see the rill that's at the Apollo 15 landing site. And I'm going to try this another time here with the lowest ISO. Okay. And let's go see. Alright, let's do this. And let's do this. Yeah, that rill is right in here. Oh, look, we can see it. I see a little bit of it right there, Daryl. Looks like a little bit of that rill.
Uh-huh.
Maybe. That's pretty cool. Let's see if we can tease out.
Mark, I found that image if you'd like to show it.
Oh, sure.
Okay, let me see if I can get it over to you.
You can dump it in the Skype chat, yeah?
Yeah.
All right. But one thing to notice, guys, is that the moon is so many different colors. All right, it really is, and from this brown to this particular stark contrast between the two types of lavas here, down to this amazing orange soil location on the moon right here. It's really amazing. You send it there, or would you put...
I did. I sent it to your regular Skype.
Okay. No problem. Let's see if I can get out of that. Okay. Okay, it's here. Oh, wow. Okay, there you go. That's very cool. Okay, we'll save that. Just a minute, guys. I'm doing this here. And now what I'll do is I'm going to bring up the photo Daryl was talking about earlier, which is really neat. You want to remind people what the photo is, Daryl, while I'm looking for it?
Yeah, this is an image of the total solar eclipse on August 21st, 1917, like at about midpoint of the eclipse. This is the moon blocking the sun in the sky, and the moon exposure was purposely shot a long exposure to where the light of the full Earth from the moon's point of view was lighting up the face of the moon, even though we couldn't see it by eye.
There it is.
And so there are the lunar features visible during the eclipse. And there are other things going on in the picture too. You can see the corona to the left and right, top and bottom. And that little pink blob, there's a couple or three of them there. Those are solar prominences peeking over the edge of the moon. Those are great big tongues and curves of hydrogen gas jumping off the face of the sun.
Following the magnetic field lines
behind the edge of the moon.
Yeah,
I'm sorry.
I was saying those follow the magnetic field lines, like these coronal. These are called coronal streamers, and you can see where it comes off here and here. Okay, and it looks like it originates in here and spreads this way. Maybe this is the north or south pole of the sun. And that really is a very, very cool picture. And that doesn't necessarily... that was funny. Did you know that there's lizard people living in our world?
I believe it.
So, yeah, that's a gorgeous picture. Well, thanks for that, Daryl.
Sure.
Thank you for thinking of us. That's really cool. All right, so nice, indeed.
Back. What were all those? Were those memes you were just flashing on the screen? What was that?
That was
lizard person.
What?
They're what?
A lizard person.
Yes, it was. No, I wasn't just showing people memes. I was showing them, this image of the sun.
Yeah.
Daryl just sent me. And then when I was scrolling, okay, it accidentally went to this one, which was something someone sent me that says, "Look, the proof that lizard people are in the world." Okay, the singer, whoever she is actually a reptilian. It's like, yeah, okay,
Funny.
Yeah, it's kind of silly, but hey, it's all right. I actually think that lizard. Reptilian type creatures may exist, but the reason is because of logic, not because of anything that convinces me. If dinosaurs are any indication here, they might start somewhere else too. And if they start somewhere else, well, then maybe they didn't have an extinction event to kill them off. And would they become intelligent? Well, we had one particular dinosaur called a Troodon that was heading toward a larger cranial capacity. The typical way we measure one conclusion nor a known destination. It's just one possible path. But it's pretty interesting to ponder the thoughts in the sky. But it gives us kind of a sky view of what's going on.
And I'm not sure what questions you touched on while I was away. We have one coming in right now, a little in the future, but Alex is wondering if you're going to stream the lunar eclipse on May 26, 2021.
Well, first,
I guess if the weather's clear.
Yeah,
maybe from Arizona.
First of all, hello, Alex Bronze. Nice to see you. We will probably do so, but the thing is, we're going to be probably here on the East Coast for that because we're committed to go with another group, including Bill Skywatcher and Keith and Paul from PK Space Imaging, and we're committed to going to New York State to see the total solar eclipse that's up there. He's asking about you're asking about the lunar eclipse. Sorry, man. Yes, I will stream the lunar eclipse for sure. I'm not going to miss it. You know why? Because the lunar eclipse, that we streamed back in January, when the moon was blood red, and I've said this before, and Amanda's heard it ad nauseum. We're one of 5 groups on the planet, one of 5 streaming groups on the planet actually, that caught the meteor that hit the moon right at the height of the eclipse. Down in the red area of the moon that was blood red from the Earth's atmosphere, we saw a flash. Poof, and that was a meteor striking the moon during the eclipse. Absolutely, utterly incredible. Utterly incredible. So you see how bright the moon is. We can't even get a shot. I mean, I can, of course. But
hold on. I must have missed something while I was away. What do I see that is green below?
Oh, that's just a lens flare of the moon. You'll notice it's basically symmetrically across the center of the image.
It almost looks kind of reversed, like the shadows on the left of the moon and the right of the green flare.
Yeah, if you notice, it's flopped. It is flopped because of the way the geometry works of the lens. Okay. Yeah, there was a lot of people on the stream when that happened. We had 5,000 people watching when that happened. If you look carefully, it looks like a green alien, doesn't it? Here are the eyes and the head, and it's looking at you, staring at you. There's people that will think that's true.
Well, I figured it was some kind of reflection, but I was wondering what was causing it. If it was just the lens, if it was just the telescope, or some kind of trickery because of the.
Yeah.
What word am I looking for?
Illusion.
No.
Oh. Well,
not the transit that the moon goes through, but like the different positions it's in.
Oh, the phase.
Like waxing and waning phases. Yeah. Like I thought it was a trick according to like what phase the moon was in at the moment.
Okay. Yep.
Yeah.
So you can see that if we take a picture where the moon looks like the moon, we end up with seeing no stars unless there's bright stars. So what we do is we actually would like to take pictures from our main view here, but what I want to do is take us to something else. So why don't we, I think if I go to Jupiter, we're gonna have to move the dome again, but that's okay, I can move the dome. Well, first of all, rather than do that, let me check my orientation out there. So okay, well, we're kind of looking a little bit to the left, or sorry, to the right, so we have room to the left to look. So I think I can actually look more toward the east a little bit. So let's do that. So we are looking here at the moon. So I think we can look about here. So why don't we look for Webb's Cross, which is a little not globular, but a little open cluster. All right, now watch the moon, because I'm now going to tell the telescope to head over there. So here we go. And the moon should just go away. Off we go.
And the great thing about watching on the stream is we don't blow out our night vision by looking at the moon and then going to something else.
Yeah. Well, it depends. If people are watching in a dark room on the screen, then yeah, their night vision get blown out.
Yeah?
Yeah. All right, so let's see. Now we are... Okay, I can't see the star because I'm not exposing long enough, but there's that star now. Okay.
And Bobby's dying to know if we're going to see Neowise again before the end of the stream.
I don't think so, Bobby, because it went behind the building already, so I'm sorry.
But well, I'm not sure how long the stream's been going for now. You can try to scroll back to the beginning. We were there at the beginning of the stream for a while.
Yeah.
Or once this is over, it will be uploaded, so you can always check back in an hour or so and watch from the beginning. Or I mean, he's been streaming for the last 2 weeks at least, streaming Neowise. So
yeah.
Usually at the beginning of the night. So any previous stream in the last few weeks, you'll definitely get great images. It's dimming now, so ones from a week or so ago will be even more vibrant and clear for you. So do check them out. Subscribe and hit the bell while you're there.
I will.
Plug.
So here's a cluster. Again, when we're seeing things like the moon, we after the moon will tend to brighten our sky and remove nebulae from something we can view normally. But this is Webb's Cross, and I just tried an exposure. The exposure I just did was 320 ISO, 320 ISO for 5 seconds. So I want to maybe go to say probably 13 seconds at 400. Daryl's back.
He's back.
I know. Good. Okay. Alrighty, and so this is Webb's Cross, Daryl, cluster, open cluster, and this is 320 at 10 seconds or 5 seconds. This is 400 at 15 seconds, and you can see the increasing sky glow from the moon here showing up. And we'll take another shot of it. Let's go up to 25 seconds at 800. Okay. Now we take another picture of Webb's Cross. Alex, you got an image of the comet? Excellent. How'd it come out?
Yeah, I was just asking him how he captured it.
Oh, okay. Yeah, no, we're always
telescope or a fancy camera, or
yeah, we're always interested in people showing us their work.
Speaking of,
so
for those that might be on Facebook, we do actually have a companion site over on Facebook, and all the images Mark takes on streams like we're doing right now, he will put in the Facebook group, so you can check them out. You can download them and play around with them, stack them. He'll put up stacked and raw images, so feel free. Make them your wallpaper in your background if you want. Just enjoy them, share with friends. And if you have any yourself that you want to share, please feel free. We'd love to see them.
Yeah, absolutely. We love doing that. So Webb's Cross here, you can see, is actually, well, in terms of its altitude, you know, it's only 25 degrees above the horizon. So it's still in some of the sky glow, but we can actually find, for instance, if we go up to the Eagle Nebula right now, all right, let's see if we can do that. We'll go to the Eagle, but first of all, let me bring us back here so you can watch it go. I know you like to watch it go. All right, so here we go. Let's see if we can do this. Here we go. It'll vanish now. Boom. And we'll head to a bright star, because I have the telescope set to do this precision pointing. So it goes to a star it knows in the database, and we'll bring that star into the center, which is right there. Here it comes. All right, and it's going to move it to a specific spot. And when it moves it to a specific spot, then it races up to this location, which is the Eagle Nebula. And we recognize the Eagle Nebula here. You can't miss it once you've seen it a few times. And the Eagle is a beautiful location. So now that we have it here, I'm going to take us to the east a little bit and bring the telescope north a little bit. Okay, so we're going to do a white light shot. All right, I'll show you what happens. So we're going to do, let's see, 2500 for 25 seconds, okay? white light shot of the Eagle Nebula. This means the camera's going to let in all the light coming to us from the sky at that point. And it's pretty high up. Is how high up? Well, I'll show you, because we can actually come back here, and we're looking at about 34 degrees, 34 degrees up in the sky. So at that altitude, the Eagle should be pretty nice, but instead, it looks like this. You know, it's like, wait, what's going on here? You know, where's the nebula? Isn't there a nebula here? Well, there's supposed to be a nebula here, isn't there? You know, and there is, but why don't we see it? The reason we don't see it is thanks to the moon. But we can fix that, because when we go back now, we're going to bring up our control system and come down to this filter wheel that I told you about way at the beginning. And we're going to go to filter number 1 and then filter number 2. And you'll see some stars peeking through. Okay, this is a narrowband filter. It's cutting out almost all the moonlight plus the sky glow and letting in frequencies that are specific to shooting these nebulae. All right, now this won't be quite in focus. All right, but that's because when you have a filter, the focus changes. All right, here we go.
We have some more questions if you want them.
Okay, sure.
One, unfortunately, this one goes back a little bit when we were looking at the moon, but Genghis wants to know why our moon is not more active from the tug of war between Earth and the Sun, like Io and Jupiter.
That's a good question. The thing with Io and Jupiter is that didn't work too well, did it? I don't have it. The ISO set enough. I have to go higher. The difference between the Sun and Io and Jupiter is that Io is very close to Jupiter, and Jupiter is the second largest gravity well. Earth is not very close to the Sun. It's 93 million miles from the Sun. Io is just I forget how far Io is from Jupiter, but it's nowhere near. It's the same relative distance. And so with other moons traveling around Jupiter, other Galilean moons in fact, those moons are tugging on Io, and Jupiter's gravity tugs on Io as well. So Io is constantly being kneaded like dough, and that keeps the interior feel a very different gravitational pull from the Sun when it's on the Sun side versus when it's on the Earth, on the other side, the outer solar system side. So we don't get that tugging going on, but there is a component.
Oh, it's 11 times the diameter of the Earth. It's 88,000 miles diameter. I wanted to say it's like 318 times the mass or something like that.
Yeah, but we could, I'm trying to figure out how many, I think the Sun was, what, 1 million Earths fit inside the Sun?
Oh, yeah.
Yeah, and then for Jupiter, being that it's hundreds of times the mass of the Earth, we would not be able to find ourselves that close to the Sun and be able to survive.
Yeah.
We cannot do it. Okay, so I'm gonna try and just pump this way up here. Okay, we're gonna go 25.6 for 25 seconds on the Eagle Nebula, just to show you what's going on. And we have a narrowband filter that we're looking at this with, and the narrowband filter is allowing in kind of a wider swath of narrow bands of special frequencies that come in. Frequencies to see the hydrogen alpha, which is the red hydrogen glow. But I think we're just we might actually be getting clouds. All right, let me go see. Let me take another shot of the moon here, and this time I'm gonna actually I'm at the Eagle, so I'm gonna be able to take a longer exposure. I want to see what I'm looking at here. We're gonna go to 6400 and because our trip might end real fast here. Okay, let's go to 25 seconds for 6400 here on the moon. Not the moon, the Eagle Nebula with the smaller camera on the top of the scope that we're using. I automated that one too, just to kind of allow us to see what's going on there. It might be clouds, and if it's clouds, then we'll be done. Which is too bad.
Well, we have another great question and a request before we call it a night, just in case. Hopefully there's no clouds and you can keep going, but this is a really good question.
Okay.
Tim wants to know, Mark, have you yourself ever seen any of the many near-Earth asteroids that have passed from your observatory?
Yes, I have.
Tell us all about them.
Yeah,
please.
We
weren't going to let it go with just a simple yes.
No, I know. Of course not. No, we actually had a night where we did this. Oh, yeah, look, it's all clouds. That's the telephoto, the wide shot. So we have big cloud banks, so we're not going to be able to see anything else. All right, so that said, let me answer the question before we have to call it. And I was going to go to Jupiter and Saturn. It would be a good night.
While you're answering the question, I know Bobby would love if you could show us some pictures of the comet you took earlier, or even from previous nights. Could we look at that in the background while we're addressing Tim's question?
Yeah, I can show you. I can show you the comet that we took just earlier tonight.
Yeah, and especially for latecomers too. So.
Yeah, absolutely.
Yeah, thank you.
Let me just get this. Okay, the comet Coma, that is the beautiful structure of the coma. Let me see if I can get a better shot here. I know I took some other shots. There we go.
Considering you're saying it's like so much dimmer, that is gorgeous.
This is beautiful. And this
is absolutely beautiful. Yeah.
I mean, you may wonder, why is it at the bottom of the shot? Well, because the tail's going this way, and I wanted to see how much of the tail was left. The tail was really getting quite short as time has gone on. P&K Space Imaging, Keith is here. You had Saturn dialed in tonight, so that means it looked like a good night finally in Miami. About time. Yeah, we're all done over here. Okay, Keith, because we have clouds. We have a wide-angle camera that we just had here, and this is the view, the cloud view. So we don't get much more tonight, unfortunately. And that means, of course, I have to close up the dome in case there's precipitation coming with any of these clouds. And yes, Bobby Burgess, that was the comet right there. That beautiful green. It's just gorgeous. We did this earlier. Yeah, and that was Neowise. Yep. These are stars, obviously, in the background. You can see the tail is sort of going out this way a little bit. Yep, looks nice. And this is actually, but when we were photographing it here, we're actually looking at it through clouds. Where, the sea clouds are coming in. You see the difference between this shot and this shot? You see this darker up here, puffy over here, and over here, it's a little darker over here, puffy over here. We're looking at the clouds moving in. And then here, it's getting troublesome. And of course, we shot the moon too as well. And the moon looked beautiful. We can see some really nice details down here, just below Tycho. We have Clavius right here. We did that tonight. It was beautiful. And we did a little quiz for all of you with the 2001: A Space Odyssey. This is the location of TMA-1, which is, the Tycho Magnetic Anomaly 1, which was in the 2001: A Space Odyssey show. It's why Heywood Floyd, the scientist, was heading over to Clavius Crater, where the moon base was. And from there, they took a moon bus over to Tycho to look at the anomaly. So, really interesting, yeah. A great movie. So, anyway, folks, I am pretty sure that we're done for tonight. I don't want to be, but we are. So, I have to go out.
Did you tell Tim your stories yet? No.
About the asteroids?
Yeah.
Oh, well, I didn't really, but I can't
Come
remember.
on, a bedtime story before we call it a night.
Yes, well, once upon a time, there was a near-Earth asteroid that was coming very close to Earth, and everyone was saying, oh, it's going to hit us, it's going to kill us, it's going to destroy us. But it didn't. It actually went by so fast that it was hard to keep it in the telescope view. And this wasn't the stream, by the way. I had no time to stream, because if I took the time to set up the stream, I would have lost this asteroid, because you actually watched it move through the field. You could see it moving in the field. And I was thinking to myself, I gotta stream this, I gotta stream this, I gotta stream this. But I couldn't stream it. It went really fast. And literally before the night was done, it had traversed the entire sky. It was so close. But it was also very small and very faint. So it didn't look all that exciting, but it was a really interesting thing to look at, because you actually see that the universe is changing right before your eyes, and that's just so cool. The universe changes right before your eyes, because you're so used to the universe just being static. You look at the stars. Orion's belt always seems to be in the place it was always in. Betelgeuse always looks the same. You're looking at those stars in the past, at some time in the past. In fact, if they're 1,000 light years away, it took 1,000 years for the light to get here. All right, so you're seeing it 1,000 years ago. Betelgeuse, you're seeing 750 years ago, roughly. So, what that means is that Betelgeuse is going to be going supernova, probably, they say, within 10,000 years. But it could already have gone supernova, and we won't know for another, anywhere from tomorrow to 749 years from now, roughly. So, that's the thing about the universe. It's so vast that the light from these objects takes time to get here. Remember, the sun is 8 minutes old. Okay? That person that you're sitting next to in the restaurant is a fraction of a nanosecond older. That light is a fraction of a nanosecond older than they are. So, interesting. But hey, I will leave you with the Clavius Tycho image as we go, because we will be back on the next clear night. I thought it was going to be clear for longer. I do want to thank all of you for coming, and you guys are fantastic. My loyal viewers with Amanda and I and Daryl. So Raoul Duke, thank you. You can see your house. Here's your house right there. This crater, it took some doing, but you managed to get a hold of that real estate. Anyway, and beware if anyone tells you that they want to name a crater after you or a star. Yes, you got a finder chart to your star, but you know what? There's no star named after you. They're not scams, effectively, but they can't officially name a star for you. And the reason is because the International Astronomical Union has to get involved, and they name everything. So, there's no way that you're going to get a star named after you. The IAU doesn't know you, and you're not a famous scientist, so you're not going to get a crater named after you. So, if they're naming a crater after you, then it means, you are probably already dead. So, it's probably not a good thing. If they're going to say they're naming a crater after you, it means someone's out to get you. Probably a good time to go, because I also smell my dog let one go in here. It's like really tough. Hey, easy there.
I used to have a friend named, his name doesn't matter, but my friend had a German Shepherd named Barney. And we would play Scrabble at the dinner table in the evening.
Yeah.
And Barney would go lay under the table, and that dog cut the most horrendous gas you ever smelled in your life. We'd be sitting there scrabbling, and all of a sudden, boy, your eyes would start watering, and everybody would go, Barney!
That's what's happening right
get
now.
Up and give us this real rueful look and walk off, and then he'd come back and be this Barney.
Yeah.
Good night, everybody.
Jeez. All right, guys. Thank you, guys. I will be back on the next clear night. And we love you all. Thank you so much for coming out to the SkyTour LiveStream. And keep looking and keep listening on our Facebook site, SkyTour LiveStream with Mark D'Antonio on Facebook, and KGRARadio.com with SkyTour Radio, where you can listen to me and Amanda and Daryl as we do our show Sunday nights 8 to 10. The second hour was by popular demand. So we will be on there too. So that said, I gotta go because it's hard to breathe in here. Gosh, it's almost like
Barney.
Yeah, Barney. Oh. Okay. That's probably gonna leave a mark too. You know, it's like, all right. Well. No.
That's funny.
yeah, because you're not here. If you were here, you would probably pass out, and I'd have to drag you out of the room just to save your life.
My eyes are watering from here.
That's right. It's the watering of my eyes. Okay. All right, folks. You guys have a good night, and we'll talk to you again soon. See you later. Remember, if you go outside, make sure that you keep looking up.
You never know what you'll say.
Exactly. Good night, all.
Good night, all. Barney.